Hello friends, in this video I am going to take this topic, color reactions of amino acids and proteins. This is one of the practical which you were doing in your first year exams. So let's get started with this topic. So here we are going to do the theory of this topic. So amino acids and proteins, they react with various reagents and give color. These reactions give color. Such reactions are known as color reactions of amino acids and proteins. Sometimes different reaction give different color with different amino acids. So they can be used for the detection of that particular amino acid, right? These can be used for qualitative detection of proteins. It can also be used for quantitative detection of amino acids and proteins, right? Here some reactions are based on the amino acid residues. Some reactions are based on the peptide bonds, right? That's why we have color reactions for amino acids also and for the fully formed proteins also, right? So let's get started. The first one, basic one, is Ninhydrin test, and this test gives positive color as purple, right? Purple color is the positive Ninhydrin test, and this test is for alpha amino acids, but you know that proline and hydroxyproline, they are not alpha amino acids. Or you can say that in case of normal amino acid, first let's take the example of a general amino acid. You know, we have carboxy group on one side, amino group on other side. This is called alpha amino group because this central carbon is alpha carbon, right? So alpha carbon is having its alpha amino group, and this amino group is free, also called primary amine, right? That nitrogen is attached only to one carbon. But in case of proline and hydroxyproline, what happens that this is amino group, this is side chain of proline. The side chain of proline is attached to this amino group, making a ring structure called pyrrolidine ring, right? So I will say that this amino group is a secondary amine because nitrogen is attached to two carbons. So this is not a alpha amino acid, so it is a secondary amino acid or secondary amine, that is proline and hydroxyproline. So all the amino acids give purple color with Ninhydrin test, but proline and hydroxyproline, due to their secondary amino group, they react differently with Ninhydrin reagent, and these both give yellow color, right? They react differently, okay? Now this Ninhydrin test is also the basis of fingerprint. There is a Ninhydrin spray. Ninhydrin spray can be used for taking fingerprints, and the basis is this, that in the fingerprints, in the fingers we have sweat, and there are amino acids in the sweat. Ninhydrin react with these amino acids to give purple color, right? So that's why fingerprints can be obtained by Ninhydrin spray, right? Also, another use of Ninhydrin test is in chromatography. In chromatography, we have to stain the amino acids At here also most of the time the staining agent used is Ninhydrin agent, right, reagent. Okay. Then coming to the next test, that is biuret test. Name is telling you something, so let's see that. Bi stands for 2. In this test, for this test to be positive, minimum 2 peptide bonds should be present. Minimum 2 peptide bonds should be present, and you know 2 peptide bond means tripeptide, right? 2 peptide bond means 3 amino acid, so it is a tripeptide. Tripeptide and proteins give biuret test positive. So can I say that amino acids and dipeptides do not give this test positive, right? And I can also say that a free amino acid will give Ninhydrin positive. A free amino acid will give Ninhydrin positive but biuret negative, right? Now here biuret positive test is also purple color, right? Now use of this biuret test is for the quantitative, it is for quantitative measurement of proteins, right? Now next, coming to aromatic amino acid color reactions, there are many under this heading. One is Xanthoproteic test. So here I am going to list all of them, then I will be taking them one by one. Xanthoproteic test, which is for all the aromatic amino acids. Then Hopkin-Coles test for tryptophan, for indole group of tryptophan. Then Obermeyer test for indican group of tryptophan. Then Millen's test for tyrosine, and Pauli's test for tyrosine and histidine. Okay. So let's take them one by one. Xanthoproteic reaction, Xanthoproteic positive test is yellow color. This Xanthoproteic test I told you for all the aromatic amino acids. Example, tyrosine, tryptophan, but it is not given positive by phenylalanine because the benzene ring of phenylalanine do not react with this reagent here, right? So phenylalanine will not give this Xanthoproteic test positive, right? In this test we use nitric acid, right? And this is the basis of yellow color caused to the skin when we are handling nitric acid in the labs. You must have noticed this thing, that your hands turn yellow, they have yellow stain on them. This is because of this Xanthoproteic reaction, and your sweat again in the hands, in the fingers, your sweat has amino acids, so they will be reacting with nitric acid to give Xanthoproteic reaction occurring there and giving yellow color, right? Then Aldehyde test or Hopkin-Coles test, which is for the indole group of tryptophan. For indole group, it is a ring test. It is a ring test. There is a purple colored ring at the junction. Also, can you tell me 2 more ring tests which we do in biochemistry? Like there is a ring at the junction of 2 liquids. One is Molish test, which is for carbohydrates. It is a general test for carbohydrates. Other ring test is Rothera's test. Rothera's test, which is for ketone bodies, and here also purple color ring is there. In Molish test also purple ring, in Rothera's test also purple ring, right? Then coming to Obermeyer test, which is for indican of tryptophan. What is indican? Indican is a metabolite of tryptophan, a metabolite of tryptophan which is secreted in urine, right? Now, this Obermeyer test is therefore also called urine indican test, right? And the positive test gives blue or violet color. So, blue or violet color, see this indican color chart, no color means normal levels and the color going on increasing in this list, light blue, blue, violet, jet black. So, the more the color, more tryptophan is there in the body, right, or in the urine, right. So, what are the uses of this test? Obermeyer test or urine indican test is positive in case of high protein diet, when we have more of tryptophan, especially in the diet. It is positive in case of overgrowth of bacteria in the intestine, overgrowth of bacteria, intestinal bacterial overgrowth, and it is positive in case of Hartnupp's disease, which is a defect in the absorption of tryptophan, if you remember Hartnupp's disease. Now, indican levels are directly associated with bacterial activity in intestine. So, let us see how. You know, tryptophan is there in the intestine from diet. When it is not absorbed or if it is high in amount, then it is taken by bacteria, intestinal bacteria, and they will do deamination of this tryptophan. There will be formation of indole, right. This indole will be taken by enterohepatic recirculation into liver, and in liver conjugation will occur, conjugation, hepatic conjugation will occur, leading to the formation of indoxyl sulfate. The conjugation is done with sulfate here, right. Then sulfatase enzyme will remove this sulfur and there will be formation of indoxyl, which will be excreted in urine, right. And now on exposure to air, it will be converted to indigo blue, which is the basis for blue or violet colored urine indican test, right. Now, in case of Hartnupp's disease, there is increased urinary indican due to bacterial degradation of unabsorbed tryptophan. Also, there is defect in kidneys, that there is increased excretion of tryptophan in urine, right. So, we are done with the test for tryptophan, right, that is Hopkin-Coles and Obermeyer test, right. Now, coming to Millen's test, which is for any phenol compound, phenyl group, phenyl ring with OH, and the amino acid with phenol group is tyrosine, and this test gives reddish brown color, which is a positive reaction, right. So, done with Millen's. Next is Pauli's test, which is for histidine and tyrosine, which is for imidazole group of histidine and phenol group of tyrosine, and this also is a red color, says positive test, right. Then next is Sakaguchi test, which is for arginine. You know, there is guanidino group in arginine, right. So, Sakaguchi is for arginine, and here also positive test is reddish orange color, right. So, we are done with aromatic amino acid test. Now, coming to sulfur containing amino acid test. So, one is sulfur test here or lead sulfide test, and the other one is CNT, cyanide nitroprusside test. Okay. So let's take them one by one. One is sulfur test. The positive test gives blackish brown color. This is given positive by cysteine and cysteine. Cysteine has sulfhydryl group. When two cysteine join, then we have cysteine, that is having disulfide bond. But methionine will not give lead sulfide test positive, although methionine has sulfur, but this sulfur is attached to two carbons, is tightly joined to two carbons. This sulfur is not available for the reaction here, right? So methionine does not give this test positive. Then coming to cyanide nitroprusside test, which gives reddish purple or magenta color, and here any compound having sulfhydryl group, any compound having disulfide bond, that will give this test positive, because what happens here, cyanide will break this disulfide bond, releasing sulfhydryl. Cyanide breaks disulfide bond, releasing sulfhydryl. Then sodium nitroprusside will react with this sulfhydryl group to give positive purple color, right? So any compound having sulfhydryl group and disulfide bond, that will give this test positive. For example, cysteine, homocysteine, which has sulfhydryl group, and then homocysteine which has disulfide bond, right? Then diseases in which cyanide nitroprusside test is positive, we have homocystinuria, cystinuria and cystinosis, right? So we are done with sulfur test for sulfur containing amino acids. Now ferric chloride test. Ferric chloride test gives various colors depending upon the specific substrate, right? And it detects in urine, this test is done, and it detects phenyl pyruvate in urine. So it is useful for diagnosis of phenylketonuria. Then it also detects branch chain amino acids. So it is also useful for which disease? Maple syrup urine disease, right? Then next is DNPH test, that is dinitro. DN stands for dinitro. pH stands for phenyl hydrazine, right? Again, this test is also for the same two diseases for which we did ferric chloride test, that is phenylketonuria and maple syrup urine disease. And this test detects alpha keto acids in urine, and the positive test is orangish yellow crystalline derivatives which are formed if alpha keto acids are present in the urine, right? Next, coming to Guthrie's bacterial inhibition assay, which was done earlier for the screening of phenylketonuria patients, and this test is done in blood or serum. It will detect all the phenylalanine metabolites, that is phenyl pyruvate, all the phenylalanine metabolites, that is phenyl pyruvate, phenyl lactate and phenyl acetate in serum. Then next, coming to VMA spot urine test. In 24-hour urine sample, this VMA test is done. VMA stands for vanillyl mandelic acid, which is a catabolic end product of epinephrine and norepinephrine, and it is for the diagnosis of pheochromocytoma, right. Then the last one here, 5-hydroxy indole acid, which is a metabolite or end product of serotonin. So it is for carcinoid syndrome, because in carcinoid syndrome excess of serotonin is formed, which will form excess of 5-hydroxy indole acid, which is detected in urine, right. I repeat, carcinoid syndrome, there is excess of serotonin, and serotonin's end product is 5-hydroxy indole acid, so it will be coming in excess in urine, and this is the basis of diagnosis of pheochromocytoma. It is done in 24-hour urine sample, right. This is it. Best wishes to you.